AI is going to take my job in 5 years. And that's terrifying. But the reason I'm deeply emotional about being here at a school, at a TEDx conference, is actually because the first time I met my now wife, Nehali, who happens to be a preschool teacher, we spoke about a TED Talk. This was, of course, the very famous TED Talk by Ken Robinson about how schools kill creativity. And we exchanged TED Talks much like we exchanged love letters. And we happened to get married, had 3 beautiful children. And as I watch them grow, I start thinking about the challenges that they will face in the next 5, 10, 15 years with the advent of technology. The curriculum that schools are teaching today is not that different from the curriculum that schools taught when I was studying. And the challenges that they will face are going to be very different than the challenges that we faced when we were growing up or when we entered professional lives. Which then brought me to also realize that while I was just as terrified for them, I was also terrified for myself, because I run an architecture firm of about 50 people. And I see how technology is going to, in some ways, make us irrelevant. You see, architects generally are thought to be extremely creative people. We get to design the world. And it's very exciting. But when you really think about it, when you go through all of the work that we do, from conceptualizing something from a building to a city to actual execution, you find that majority of the man hours are actually spent in the execution side, which means in the coordination and creation of the drawings, etc. A lot of this have AI programs coming in to replace that, because those are things which are easily replaceable. To give you an idea of the impact, for this part, which is 80% of our man hours, for a typical large project, we would look at having 6 architects working across 1 year to be able to produce the required drawings. I foresee that AI will be able to do it in minutes. And of course, we will need somebody to check everything, review everything. But that's maybe a week. So you go from 6 architects for a year to 1 architect for a week. This is why I felt we must change how we're thinking about AI, because this is going to happen. So rather than be scared of it, we wanted to partner with it. We wanted to see how we could use it today to work towards this joint future. So we create this company called Kaizen.ai, which does optimization. Now, that's another interesting thing about where I see technology today. It is not strong enough to be able to do everything that humans do. However, we find that if we are able to use it in the correct places, we are able to do some incredible things with it. So I call it the human AI human approach, which means we still need humans to design, because there are so much complexities, there is so much differentiation. But what we do is we use AI to optimize what is designed. And again, that is checked and executed with humans. That allows us to use technology today to be able to help our buildings today. Let me give you an example of what I mean. So buildings are really a bit like puzzles, just incredibly complicated 3-dimensional puzzles, but this is actually a good starting point, where you have all of these components and you must find a way to get them to work together. We have structural requirements, toilet requirements, plumbing requirements, staircase requirements, fire requirements. So these are all requirements that are necessary to fulfill in each building. And we must find the right way to put them together. And it needs to work in a three-dimensional puzzle almost. This is something AI does incredibly well. So which is what we built. Let me give you an example of a project so it will better explain what this is and the impact of this. So this is a project we did in central Mumbai, where again, the building was to be repeated exactly the same on the side. So there was a building that was already built, which was called Ajmera Zion. And the idea was to repeat it exactly the same on the side. So it was a large master plan. Now, the building was, the building that was to be replicated, that one was already built. One, they had already started construction on site, which means you're far ahead of design. You've got design done, you've got approvals done, and you've reached site. This is not a great time to sit to optimize, redesign anything, because one can't actually change either the slab outlines or can't change really the design. Also here, the apartments were sold, so that allowed us very little impact in terms of what we could change in the building. I go back to the puzzle. So we couldn't change the apartments, but the requirements in terms of elevators, staircases, fire, all of those were actually very much mandated by code. So without changing the apartments, could we start looking at optimizing this portion only? What we were able to do is keep the same ingredients in terms of number of elevators, number of staircases, fire requirements, sizes, and we were able to reduce the area that takes by 27%. That's a huge number because this multiplies, right? It is 34 residential floors across 2 towers. There is something called FAR, which is very, very valuable. We were able to reduce that by 11%. The other interesting thing is, without changing the apartments, we were actually able to reduce the material usage by almost 42%. That's just by optimizing, that's just by realizing a horizontal core versus a vertical core, etc. This is without touching the apartments. This is, the architect's vision is still alive and well. We're not touching any of the outside. We're actually changing the infrastructure inside. Now, what happens in terms of the lower levels? Again, it's parking. We know what's the size of the car park. We know what's the size of the driveways. We couldn't change the outline. We went from a rather difficult to use ramp where you're doing a U-turn on a ramp with 83 cars on a floor to 145 cars on the same floor. Now, again, there is the architect's vision in terms of what is the outline of the building, what does the building look from the outside, how does the apartment work, what is the apartment footprint. All of that is unchanged. It is only talking about what is inherent and how do you use the 3D puzzle to find the most optimum way of doing it. So just to give you an idea of what we were able to do on this project, because now we were able to fit in all of those 8 floors of parking into 4 floors, we went from 30 residential floors to 34 residential floors of the same height. What did that mean? You are able to increase the usable area by about 13%, but at the same time, your area that you are constructing, which would otherwise be increased by about 26%, has actually reduced by 25%. The FAR, which is the baseline of how buildings are put up, are actually reduced by 11%. So these are all competing objectives without changing the design or the master idea has not changed. And we reduce the material consumption by 41%. The environmental impact of this, because you have the embodied carbon, which is the carbon that is used But remember, all of the areas that we reduced are areas that are the common areas, the parking areas, which require to be electrified, which require to have sprinklers working 24 hours a day. Across the 75-year life of a typical building, we're talking of a reduction of 1.6 million metric tons. Between the building right next door, which is the exact same building, our carbon footprint reduced by 44.5%. Same architecture. The financial side, while we reduced the carbon footprint by 44%, the profitability actually went up by 18% because now you have more apartments to sell, but you're constructing far lesser. We've been able to do this now around the world. We've done this in Dubai, Saudi Arabia, US, a bunch of places. But I come back to the initial thesis. Human, AI, human. Even within how this company works, even when we do the optimization, you don't take what iterations it spits out. The way this works is that we run 10,000, 100,000 iterations. But again, humans check it to test what works and what doesn't work for that particular project. Then we have experts check, does it work as per the codes? Does it work as per structural codes? So our belief is at all points to be able to magnify human ingenuity with AI. We've been at it for a little while. We've been able to actually reduce about 65 million metric tons across just the projects our small firm has done. On average, we've reduced about 15% across our projects of carbon emissions. You know what does that mean? That's equal to 1 month of global commercial airline traffic. Carbon emissions of 1 month. That's just across 150 projects. And this is, again, without changing the architect's vision, without changing the architect's idea. 40% of worldwide emissions are done through buildings. If we were able to reduce even 10% of that, just through optimization, we're talking about 2 billion metric tons, which is equal to 65% of all of India's carbon emissions. The challenge with buildings is that they don't, when you construct it, there are a certain amount of emissions. The challenge is what happens across the 75-year or 50-year or 100-year life cycle. It's using energy every day. So that inefficiencies exist throughout. We've been able to increase tangible profitability by about $5.4 billion US. If we were to better use that same money, the social infrastructure we could create, just if we were to look at India, that would mean we would be able to add 5 schools per district in all India, or 1 hospital for each, or per 4 districts all over India. And this is only across the 150-odd projects that we've worked on. So I start again with where I led in the beginning, that what a typical architecture firm is doing, AI is going to take our job in 5 years. But when I think about my children and the world they will live in, I'm actually very positive about it. Because I think this technology is not us versus AI. We need to find a way to make it us plus AI.